Welcome to our class today, where we'll be looking at solving systems of linear equations. You must be aware that when we talk of systems of linear equations, we mean a collection of linear equations. So to solve means getting solutions to this system. Remember that a system that has solutions is referred to as a consistent system, while that has no solutions is referred to as inconsistent. Consistent system and inconsistent system. So as I've already said, a consistent system is that has solutions or a solution, while inconsistent system is that has no solutions. So we'll look at examples on how to solve systems of linear equations. And our first example will be solve 3x plus 2y minus z equals to 1, x plus 4y minus 3z equals to 11, and negative 2x plus 3y plus 5z equals to 21. Now, so we have various methods of solving systems of linear equations. We have Cramer's rule and several other methods. But today I'll be using augmented matrices, where after writing augmented matrix, I'll try to do elementary operations on that matrix formed and try to solve the system if it has solutions. So we have this as our question. This is our system of linear equations. So for me to solve this, what I want to do is to extract an augmented matrix out of this. And an augmented matrix is just a matrix formed of the coefficients of this x, y, and z. So the augmented matrix for this system will be 3, 2, negative 1, 1, 1, 4, negative 3, 11, negative 2, 3, 5, 11. No, let this one be 21. Let this one be 21. So we have got 21 here. Let it be 21. Now, so to solve this, I want to look at this main diagonal. So I'll come to this first element in this diagonal and use this element to clear the elements below it in the column, first column. So that in this first column, this should be the only non-zero element, and these other two should be zeros. And then along this diagonal, I have this element here. I'll use it to clear the elements below it. So I'll not be touching elements above it. So I use this element to clear those below it, so that what I mean by clearing is that I make this one 0. And then along the same diagonal, I have this element. If other elements would have been below it, I would have made them 0. But fortunately, we have no other elements below it. Now, whatever thing I'll be doing to make this one 0, I'll be doing it for the entire row. So whatever thing I do for this element, I do it for the entire row. And what I'm doing for this element, I do it for the entire row. Likewise, what I'll be doing for this element, I'll be doing for the entire row. So we don't do it for one element only. Now, so for me to create a 0 in this position, what I want to do is to have a 1 here, so that this 1 subtracted from this 1 will give me a 0. So how do I get a 1 in this position? I get a 1 in this position by dividing this element by 3. And that means that I'll divide the entire row by 3 and then subtract from this other. It would have been easier just interchanging the first and second row, but let's just do it the way we've already stated we'd be doing. So what I've said is, since I need a 0 in this position, I'll take row 2 minus row 1 divided by 3. Good. So that one we're just doing it mentally. So let's write what happens. The first row remains the way it is. The first row remains the way it is because we've not touched it. We're just doing it mentally. So this divided by 3 is 1. Subtracted from this 1, I have a 0 in this position. This divided by 3, I have 2 over 3. And then subtracted from row 2. Row 2 has a 4 in this position. So what I'll be having will be 12 minus 2, which is 10 over 3. And then in this position, divided by 3, so I have negative 1 divided by 3. And then subtracted from row 2. Row 2 is negative 3. So you realize that this negative and this negative will be positive. So I have negative 9 plus 1, which will be negative 8 over 3. And then we are now in this position, this column here. This one divided by 3, I'll be having a third. And that a third subtracted from 11, I would get that 2 over 3. That 2 over 3. Now, so we are here. We need to create a 0 in this position. Again, we're using this element. Remember, we said that we use this element to create zeros below it. So, to create a 0 in this position, I need a 2 here, so that a 2 plus this negative 2 will give me 0. To get a 2 in this position, I only need to multiply this element by 2 over 3. So in other words, we are doing it for the entire row, and so what we are doing is we are taking 2 over 3 of row 1 and we are adding it to row 3. We are adding it to row 3. So 2 over 3 times that will be 2 plus this will be 0. 2 over 3 of this will be 4 over 3. 4 over 3 plus 3 will be 13 over 3. Okay, we are here. 2 over 3 of this will be negative 2 over 3. added to 5, you get 13 over 3. And then lastly, 2 over 3 of this would be 2 over 3 added to 21 would be 65 over 3. 65 over 3. Okay, so the next thing we come to the second element in that diagonal. Just a minute. So our second element in this diagonal is 10 over 3. 10 over 3. So that 10 over 3, we use it to create zeros in the elements below it. So we create a 0 here using that 10 over 3. Create a 0 in that position. So to create a 0 in that position, what we want is to have 13 over 3 here, and then subtract from this 13 over 3. How do we achieve 13 over 3 in this position? We achieve 13 over 3 in that position by multiplying 13 over 10 by 10 over 3. So 13 over 10 by 10 over 3 will give me 13 over 3. So what that means, therefore, is that we are doing that for the entire row. An entire row 2 multiplied by 13 multiplied by 13 over 3. So 13 over 3, or 13 over 10, 13 over 10 times row 2, subtracted from row 3. Subtract that result from row 3. So what do we get? Row 1 remains the way it is. We have not touched it. Row 1 remains the way it is. Row 2 also remains the way it is. 10 over 3 negative 8 over 3, that 2 over 3, and then just move this on this side. Then we are we are working on row 3. So we've said that we would multiply 10 over 3 times row 2. So 10 times 3, 10, no, 13 over 10, 13 over 10 times 0, subtract from 0 will give us a 0 in this position. And then 13 over 10 of this, 13 over 10 of 10 over 13, no, 10 over 3, of 10 over 3, this gives me 13 over 3, 13 over 3. So 13 over 3 from this, I have a 0 in this position. And then 13 over 10 of negative 8 over 3. 13 over 10 of negative 8 over 3 subtracted from 13 over 3. Subtract from 13 over 3. So you realize that this and that will give us positive, and so our LCM will be 30. And so when we do that, we'll get 130 plus 13 times 8. 13 times 8 will be 104. Will be 104 over 30. So this gives us 234. 234. Let's submit. The space is too small for us. Okay, 234 over 30. And again, doing the same, 32 over 3 times 13 over 10 subtracted from 65 over 3 gives us 234 over 30. So remember what we've done. What we've done at this point, we took 13 over 10 multiplied by 32 over 3, and this result we subtracted from 65 over 30. That's how I got this 234 over 30. Okay, so once we reach at that point, we've already done what we wanted to do using our diagonal here to create elements below it to be zeros. So just done that. Once we achieve that, then we can write the equations. The first equation here means 3x plus 2y minus z equals to 1. The second equation here means 10 over 3y minus 8 over 3z equals to 32 over 3. And the last equation here means 234 over 30 z equals to 234 over 30. Now, at this point, we solve from the bottom going up. Solve from the bottom going up. So let's do that and so we get. So solving from the bottom, the last equation here, we can see that it implies z equals to 1. Z equals to 1. Because you just multiply by the reciprocal of this on both sides. The reciprocal of that on both sides. So z will be 1. So we now move to this equation and find y. So it means what we are given there is 10 over 3y equals to 32 over 3 plus 8 over 3z. But z is 1. So what we have on our right side is 40 over 3. On our right side is 40 over 3. So what will y be? So multiplying by the reciprocal of 10 over 3 on both sides, we would have y to be 4. Y will be 4. So after getting z and y, we now move to the first equation here, substitute the value of y and z, and then get x to be, I was getting x to be -2. X to be -2. So generally, these are our solutions. X is -2, y is 4, and z is 1. So normally, this equation is written in the form of a column vector. You can write it as in the form of a column vector or in form of a row vector. So let's write it as an ordered pair. Let's add it, write it as 2, 4, 1. So this is our solution to the system, the above system. So our solution to above system. So you can write it this way, or generally people write it, most books will write it in this form. So I would want us to look at another example about to solve a system of linear equations, and then we look at a consistent system again, and then look at an inconsistent one. So solve. I want us to solve 2x minus 3y plus z equals to 2, 3x minus 4y plus 3z equals to 7, 2x plus 3y plus 2z equals to 8. Okay, again, let's extract augmented matrix from this. So we have 2, -3, 1, and then 2, we have 3, -4, 3, 7, 2, 3, 2, 8. We are looking at this main diagonal, and we are using the elements along this diagonal to clear those below it. That is what I mean is I use this element to make this one 0, and use this element to use this one 0, and this element to use those. If we had any below it, we would have made them 0 using this element. So for me to create a 0 in this position, I want to use this element to create a 0 in this position. So I'll multiply this element by 3 over 2. Note that if I multiply this one by 3 over 2, I would have 3. Subtract from this. So what I mean is we are doing it for the entire row. So we are multiplying row 1 by 3 over 2 and subtracting the result from row 2. Subtracting the result from row 2. Let's see what we get. So row 1 remains where it is as 2, -3, 1, and 2. Okay, so let's multiply this one by 3 over 2. You get 3. Subtract that 3 from this. we would have a 0 in this position. Multiply this one by 3 over 2. So what we have is 3 over 2 multiplied by negative 3. That's what we are doing. Then the result subtracted from negative 4. The result is subtracted from negative 4. So this will give us positive 9 over 2. Positive 9 over 2. So this operation, doing this, would get half. Get a half. Because this would be negative 8 plus 9. Okay, so we are here. This one by 3 over 2. You get 3 over 2 and then subtract it from 3. Subtract it from 3. So this is 6 minus 3, which is just 3. This will be 6 minus 3, which is 3 over 2. And then doing the same for this. This one by 3 over 2, we'd have 3. This one multiplied by 3 over 2, we'd have 3. That 3 separate from this, get a 4 in this position. So we achieved what we wanted in the second row. We come to the third row and we want a 0 in this position. This one is easy because we just need to subtract this from this. So we are doing that for the entire row. So what I mean is we have row 3 minus row 1. So when that happens, we'd have a 0 in this position. We would have a 6 in this position. And then we would have a 1 in this position. And a 6 in this position. Good. So what is left is to use this to create a 0 here. Let me erase here. Create some space here for us to use. So for us to create a 0 in this position, we want to have a 6 in this position and subtract from this. So how do we get a 6 here? By multiplying this row by 12. So what I mean is we should have 12 times row 2 subtracted from row 3. So row 1 remains the way it is because we've not touched it. And row 2 remains the way it is because we also have not touched it. Whatever thing we are doing it mentally. So this one times 12, no, this one times 12, from this would have a 0. This one by 12, we get a 6. 6 from this will give us 0. And this one by 12, give us 18. 18 from this give us negative 17. So it was this one by 12. This one by 12 would be 18. 18 from this be negative 17. This one by 12 would be 48. 48 from this be negative 42. So what does this mean? What this means is that We have the first row here means 2x minus 3y plus z equals to 2. The second row means a half of y plus 3 over 2 of z is 4, and the last one means negative 17 of z is negative 42. So we solve from down going up as we did in our first example. So when that happens, the equation at the bottom means that z equals to 42 over 17. Substituting here 42 over 17, we would find y to be, I was finding y to be 10 over 17. And then x would be 11 over 17. So that our solution is 11 over 17, 10 over 17, and then 42 out of 17. That would be our solution to that system. Let's look at another example. Solve 2x plus y minus z is 3. Negative x plus y plus 2z is 3, and x minus 2z is 1. Now this one I leave it as an exercise, and you need to get the solution to this as the solution is negative 5, 4, and negative 3. So this is the value of x, the value of y, and the value of z. So you try that and see if you obtain that result. Another example. Solve x plus 2y minus z equals to negative 3. 2y minus 2z equals to 1, and x minus y plus 2z equals to 3. Okay, let's solve this. Let's see whether it is consistent or inconsistent. We extract our augmented matrix. This was x. So augmented matrix will be 1, 2, negative 1, then negative 3, 0, 2, negative 2, then 1, 1, negative 1, 2, 3. So we need a 0 in this, as luckily we already have a 0 in this position. So what we want is a 0 in this position. And we're using the elements here, these elements. So we'll have row 3 minus row 1. So row 1 remains where it is. Row 1 remains where it is. Row 2 already has a 0 in the position we want. So we just leave it the way it is. So row 1 from row 3 we get a 0, and then we'd have -3, and then we'd have 3. Just subtracting this from this, we have a 3. Then this from this will give us a 6. So I now want to use this element to create a 0 here. What I'm saying is that I should multiply this element by 3/2 and then add it to this element. So this one by 3/2 added to this, get a 0 in this position. So I'm doing it for the entire row, in the entire row. So this entire row I multiplied by 3/2 and then add it to this entire row. So let's see what we get. The first row remains where it is. The second row remains where it is. And then this one by 3/2. No, this one by 3/2 added to this will get a 0. This one by 3/2 added to this get a 0. This one by 3/2 added to this get 0. This one by 3/2 added to this get 7.5. Get 7.5. So what does this imply? This implies that we have x. The first row means we have x plus 2y minus z giving us -3. The second row implies that 2y minus 2z will give us 1. And then this other row means you have 0x plus 0y plus 0z giving us 7.5. But you notice that the one at the bottom, this row here, this equation, is impossible. That we cannot get solutions of x, cannot get values of x, y, and z, such that when you multiply them with the zeros, you'd get 7.5. Because this will just give you 0. Whatever values you have, the left side will give you 0. So it will not be equal to the right side. So that means this is not possible. And therefore we say that this system has no solutions. Because we cannot find those values x, y, and z. We cannot find those values x, y, and z, which will multiply by 0, and then plus 0 times that, then plus 0 times that will give us 7.5. And hence, this system has no solutions. Has no solutions, or is inconsistent. Is inconsistent. So that is how we solve systems of linear equations by use of these augmented matrices and elementary row operations. But as I said, we have several other methods. In our other videos, we look at other methods of solving systems of linear equations. Thank you.